Now is just look at the board. We have something that is very, very clear. The diagram on the board has to do with something we already know, that has to do with how a particular metallic substance can be electroplated. Okay, so now let's see this. The application of electrolysis. One of the applications of electrolysis is electroplating. This is electroplating. Then the question is, what is electroplating? Electroplating simply means the process of coating a metallic object or a metallic material with another metal to give it good appearance or to improve its appearance. So from what we have on the board, electroplating refers to the process of coating a metallic object with another metal in order to improve its appearance or to prevent it from corrosion. So that's what electroplating is all about. Now, there are metals that can be used to cause this electroplating process to happen. And these metals are copper, silver, chromium, nickel, or gold. Any of these can be used to electroplate other metallic objects or metallic materials. Now let's see how we can electroplate spoon. How the spoon we know can simply go into electroplating or electroplating process. This is the spoon and this is another metal. So the diagram you see is an arrangement. It's an arrangement that has to do with electroplating. So the anode here is silver rod. The cathode is the spoon to be electroplated. That's this. Then the electrolyte here is a potassium silver cyanide solution or silver nitrate solution, so to say, which we are going to see what will happen here. But before we go into all this, we need to understand that electroplating finds wide application in various materials. For instance, the bumpers of vehicles and the handlebars of motorcycles and bicycles are chromium electroplated. So you can see chromium at this point can be used to electroplate materials such as the handlebars of motorcycles and bicycles. Also the bumpers of vehicles, of cars, so to say. So that's what happens here. Now, what is the meaning of this? It has to do with the diagram we have. Okay, it has to do with this diagram. What happens here is when current is made to pass into the system, of course, the electrolyte becomes energized. Once energized, ionic process begins. And then the anode is a silver rod. Of course, the solution, that is the electrolyte, is silver nitrate, because we want the spoon to appear in silvery form or to have the silver look. That's the reason for using silver nitrate solution, because we want the spoon. The spoon is to be electroplated, and because the spoon is to be electroplated, it is used here as a cathode. I repeat, because the spoon is to be electroplated, for it to have silver look or silver appearance, it is used in the voltmeter as the cathode. Yes, electrode, but this name is cathode, okay? That's why we use the spoon as a cathode. Now, when current is made to pass through the system, there is this ionic process. The ionic process splits the silver nitrate solution into positive ions and then negative ions, so to say. That's what you're seeing on the board. This is the silver nitrate solution. So when current is meant to pass through, it splits into positive ions and negative ions. The positive ions, which you will see around this place, okay, the silver nitrate positive ions will not drift. They will drift towards the spoon and deposit there. Deposit on the body of the spoon. Look at it. This dot you see represents silver layer deposited. Okay? Ag ion, silver ion. Because they are positively charged ions. And what the ions here are negatively charged, or rather the spoon being a cathode, being used as cathode, is negatively charged. So positively charged ions will not drift towards the cathode because the cathode, as the spoon, is negatively charged. So when they drift to the spoon, they deposit there. They deposit on the spoon as silver layer. As that continues for a long time, the entire spoon is now coated. The entire spoon is now coated with silver layer. That's what happens. And the process of doing this is known as electroplating. That's what we have learned this moment. Okay? So the ionic process is this. This is the silver nitrate solution. Silver, okay, nitrate solution. Alright? This is it. Okay? So that is it. Immediately it is energized by some amount of current. Alright? Current. It splits. Okay? Ionic process begins. And then it splits into silver ions and the nitrate ions. The silver ions drift towards the cathode, which is the spoon, and also the other one. So what happens to this? The nitrate ions remain in the solution. It's not deposited here. No, the nitrate, this one, is not deposited on the spoon, no, but remains in the solution to maintain the concentration of the solution. So that is it. This one is very simple. If there is any of these explanations that is not clear, put it in the comment section. Give me some thumbs up, subscribe, share with your friends, networks, and students. I am signing out to prepare for the second class. Next class will be hung somewhere there or linked somewhere there. See you in my next class.